Okay, this video is going to go over one of the harder ones. Given the area of a regular polygon, go ahead and then find the radius, apothem, side length, and perimeter. Again, this is kind of the backwards problem. But if you just knew the area of a regular polygon, how could you find the other parts? So let's go ahead. Let's do one that we can't even draw. Let's do a nonagon, okay? So let's say the area, it doesn't really matter what it is. Let's say it's 100 square feet, and it's a regular nonagon. Okay, so that's a regular 9-sided figure. Okay, so what we want to do, let's establish a couple of things. What's the interior angle and the exterior angle for a 9-sided? Okay, so we take 360 and divide by 9. We're going to get the exterior is 40, which means the interior must be 140. Okay, so I'm just going to draw the little triangle. Again, how many of those are there? Well, if this is a 9-sided figure, there are 18. Just a reminder, 18 little triangles like that. If the interior angle is 140, then the little triangle bisects it, which makes that 70 degrees. Okay, so what we don't really know any of these things right now. We don't know the radius, we don't know the height of the little triangle, which is the apothem, and we don't know x. And if we double x, we get the side length. Okay, so here's what we're going to do. We're going to relate both h and x to the radius. So let's use cosine. Cosine of 70 should be x over r. If I multiply both sides by r, I get r cosine of 70 equals x. Okay, now I'm going to do sine of 70. Sine of 70 is h over r. So then r sine of 70 is equal to h. Okay, just like we've always done, except now they're just in the abstract, meaning they're with letters, variables, rather than numbers. Okay, so then what did we say about the area of the nonagon? The area of the nonagon should be 18 times the area of the little triangle. The area of the little triangle is 1/2 base times height. Okay, now let's plug in. We know that the area of the nonagon is 100. We know that x really is r cosine 70, and that h is r sine 70. Okay, let's simplify this a little bit. This is 100. 18 times 1/2 is just 9. R times r is r squared. And then that's just cosine of 70 and sine of 70. Okay, this 9 cosine 70 and sine 70, that's really just a number. So let's just figure out what that number is. So 9 times cosine of 70 sine of 70. Okay, so we have 100 equals 2.8925. We won't round really at all. And then r squared. So what we're going to do now is we're going to take 100 and we're going to divide by that. 100 divided by that answer, and I get 34.57 equals r squared. And then I'm going to take the square root, and I'm going to get 5 point, looks like really close to 88, and that would be then in feet. Okay, so then given the area, I can break it down. I can write h and x in the abstract in terms of r. I know what the area is. I know the area is 18 times the area of the little triangle. The area of the little triangle is 1/2 base times height, base and height. I can then solve for r. But once you know r, you know everything else. Again, if you know r is 5.88, then you can just do 5.88 cosine of 70. And now I know x. X is 2.01. Okay? But if I know x, then I know the side length is 4.02. But if I know the side length is 4.02, I can multiply 4.02 times 9 because there are 9 sides, and I can find the perimeter. Okay, so the side length is 4.02 feet, the perimeter is 36.18 feet, and then I also can find the apothem because I can just take the r, 5.88 times sine of 70, so 8, which is the apothem, is 5.53. Okay, so I know the apothem, I know the side length, I know the perimeter, and I know the radius. And I started with the actual area of the polygon, and I had to work all backwards. The hard part here is the fact that we couldn't find numbers for x and h, but we made them both r's, and then down here we just solved for r. Okay, it really is the same steps we would do for all those other ones. It doesn't matter whether it's a nonagon or a hexagon, you're going to do this same thing. You're going to use the little triangle and break it down this way. Hopefully this helps you do that harder version of regular polygons.